In this video, we're going to be talking about single replacement reaction. Single replacement reaction occurs when one element, like a single element, replaces another element within a compound. An example, let's say we take element A and we have a compound which contains element B and element C. In this case, element A would replace element B and would pair up with element C, and then B would be left out. So the way this works is that you have to think about reactivity over here. So element A, let's say element A and element B are metals and element C is a non-metal. So a metal cannot replace a non-metal, so the metal will have to replace just a metal, which is rule 1 over here. So when a metal replaces another metal, it really depends on if A is more reactive than B. If A is more reactive than B, then A is able to pair up with C compared when B is pairing up with C, because A is more reactive. So let's look at a few examples. For example, let's take this magnesium, aluminum, and chlorine. So we have 3 magnesium atoms, 2 aluminum with 3 chlorine atoms, or 6 chlorine atoms and 2 aluminum atoms. So if we look at our reactivity chart over here, this is just for metals, we see that magnesium has a higher reactivity than aluminum. So if we go over here, magnesium is over here and aluminum is right below it. So most reactive and least reactive. So because aluminum is below magnesium, it shows that magnesium is more reactive than aluminum, so it kicks aluminum out and pairs up with chlorine. So then we get the chemical reaction, 3Mg plus 3Mg Cl2 plus Al2 over here. And so it turns from this chemical equation to this chemical equation. And also you have to understand that for rule 1, a metal can only replace a metal. A metal cannot replace a non-metal. So the only exception that can be here where metal is replaced with, where metal cannot be replaced with non-metal is when we have a metal and this non-metal is specifically hydrogen. If it's hydrogen located in an acid or a water, then what that means is that the metal is able to replace hydrogen and pair up with this non-metal over here. So what happens is that we have K and we have oxygen. So then we'll have H4 plus 2KO. And so this entire thing is the same amount, and it's just a new chemical equation. So that is the second rule. Then we have the third rule, which is almost identical to the first rule. However, instead of metal being replaced with a highly reactive metal, it's non-metal being replaced with a highly reactive non-metal. So we have bromine, we have potassium, and we have iodine. So what happens is bromine is a non-metal and iodine is also a non-metal, but potassium is a metal. So potassium stays, but iodine and bromine are the ones that are going to be switched up. So since bromine is more, and this is just for metals over here, but for non-metals we use this chart over here, and we can see bromine is more reactive than iodine. So bromine gets swapped with iodine, and then we end up having 2KBr plus I2. And another example of non-metal being displaced is chlorine over here. Then we have sodium and bromine. Bromine is non-metal, so chlorine is non-metal, but sodium is a metal, so sodium stays. If we go here, bromine is here, but chlorine's more higher up, so it's more reactive, so it replaces the bromine. So we have 2NaCl plus Br2. And these are all balanced equations, so no mass was created nor destroyed. This is all about single replacement reaction, where one element replaces another element in a compound.